one must use layered approach, or as some call it, multi-pillar approach, where a combination of simulation, control testing on a proving ground, and test tracks, and together with real-world testing, and not to forget statistical analysis at the end, as well as formal safety engineering is used, since no single method is sufficient basically nowadays. And safety evidence must come from complementary validation pillars, where each one has some specific strengths and drawbacks. Gokul mentioned many of them basically already. And if we talk about ADAS and AD systems specifically, nowadays scenario-based testing is the standard, and the different methods ensure better test coverage in different areas. But thinking about AI models, I mean, see, nowadays they are taking more and more kind of the task itself. Like if you think about end-to-end models, they are doing much everything, right, from the perception to the driving task. And that complex nature of learning mechanism behind AI models and the lack of deeper understanding behind AI models reasoning, we must admit that's the case. So we learn more and more about it, but we are not there yet, I would say. In order to make sure models are robust, without bias, accurate, etc., one must use layered simulations like model in the loop, software in the loop, hardware in the loop. Everything is needed basically to explore the design space as much as possible. Of course, simulations alone are not enough, and still real-world testing is a must, which includes orchestrated testing on a test track as well as testing in a real world with real traffic conditions. And then we need to understand how simulations in many tools available nowadays to buy from different suppliers, which are trying to simulate both camera sensors output, radars, lidars, and so on. How they actually, what's the level of realism in those? How much can we trust those simulations and so on? But I would like to go back to one point, which it's about some scenarios which are either dangerous or really hard to actually test in a real world setup. Then you need to actually go to simulations and trust in simulations in those cases. And even NCAP tests today have some scenarios which are really hard to test on a proving ground, and regulators are willing to accept simulation results.